Hello students, today we are going to discuss few reasoning questions related to refraction. Twinkling of stars. You know that stars twinkle but not the planets. What is the reason for that? Here we are discussing that only. You know that stars are very far from us. That means the light from stars reaches to us through the atmosphere. When light enters from space to the atmosphere, it undergoes refraction. But you know that atmosphere is having so many layers, and the optical density of the atmosphere is not constant. It varies with the temperature. That means when we are getting the image of the stars on one position, but there it will not be constant. What is the reason? Because the atmosphere density goes on changing, so the apparent position of the star goes on change. When the apparent position of the star changes, we feel that it twinkles. But in the case of planet, as compared to star, the size of the planet is less, but planet is close to us, so we consider it as an extended source. Stars we always consider as a point source. So what happened? You know that all the planet, it is in symmetrical shape. When you consider the symmetrically opposite points, the effect produced, because this all planet, it is made up of so many point objects. So we will consider the apparent position of each point object. Then these points, these are symmetrically opposite points. So the refraction effect produced by the symmetrically opposite points nullify each other. Because of that, we cannot see the twinkling effect of planet. The position of the planet remains same only. The effect of variation in the optical density, it will not be visible here. Is given here. The planets are much closer to the earth and thus seen extended source. If we consider a planet as a collection of large number of point-sized source of light, the total variation in the amount of light entering our eye from all the individual point-sized sources will average to be zero, thereby nullifying the twinkling effect. This only I told here also. Next topic is advanced sunrise and delayed sunset. What is the reason for that? You know that sun is visible to us when the sun crosses the horizon. Then the sun's light enters from space to earth atmosphere. It bends towards the normal. Then when you extend this, you can see the position of the sun here. This is the apparent position. So sun is visible to us 2 minutes earlier than the actual sunrise. The sun's image that is visible to us 2 minutes earlier than the actual sunrise. The same thing, it happens during sunset also. 2 minutes earlier than the actual sunrise and 2 minutes late after the sunset. That means elongation in the total time is 4 minutes. Next is scattering effect. What is scattering? Spreading of light in various directions by colloidal particle, that is called as scattering. Scattering is inversely proportional to wavelength of the light. That means scattering is maximum for blue light and minimum for red light. Tyndall effect. What is Tyndall effect? When light passes through colloidal particle, the path becomes visible. That is called a Tyndall effect. This you can see when the light enters into a dark, dusty room, you can see the path of the light. That is the example for Tyndall effect. Then the dense canopy of trees in a forest. There also you can see the Tyndall effect. The light becomes visible when light passes through a dense canopy of trees in a forest. Then color of scattered light depends on the scattering particle. If the size of the scatterer, that means the scattering particle, is fine, it scatters blue light. If the size is medium, it scatters red light. If the size is big, that means it scatters all the color, then we will get only the white light. Even larger particles scatters all the colors of light, that is why it appears white. Then wavelength of red light is about 1.8 times that of the blue light. You know that blue light, the wavelength is 400 nanometer, and the red light, the wavelength is near about 700 nanometer. Then why danger signals are made of red color? The reason is that you know that the wavelength of red light is more, so it scatters less, especially than foggy night and all. When light incident on the particle, if scatters, then the that vehicle will not be visible. Then if you use a red light, the red light scatters less, so we can say the the vehicle, whatever the signals, that we can see it. So the danger signals are made in red color. Why the color of sky appears in blue on a clear day? You know that upper atmosphere of the sky contains fine particles. When light incident on these fine particles, the least wavelength blue light is scattered more, and this scattered light enters in our eye, and we feel that the sky appears in blue color. Then how does the sky appear to an astronaut in the space to a passenger of a jet plane flying in high altitude? The sky would appear dark to an astronaut in the space. Scattering is not very prominent of such high altitude due to absence of particles. You know that in space there is no atmosphere, then the scattering is not possible. Why cloud appears white? Clouds are formed by water vapor. That means the size of the water vapor is more, so all the colors are scattered equally. Because of that, it appears in white color. Water vapor condenses to form water drops due to large size of the droplet. All colors light scattered equally. Then why colors of sun appears red during sunrise and sunset? During sunset and sunrise, the sun is near to horizon. That means the light rays has to travel more distance through the atmosphere. Then the fine particles in the atmosphere scatters the blue light, and the low wavelength blue light and its near colors all scattered off. Then the high wavelength red light, it's scattered less, that only will reach our eyes, and this is the reason the sun appears to red color during sunset and sunrise. See the clear explanation of why is the color of clear sky blue and color of the sun at sunrise and sunset with the diagram. It is given in NCERT.